Good morning, students. Once again, I welcome you to my video lectures on network analysis. Today, I will continue with the phasor concept. Already, I started with the definition of phasor. Then, next topic is what is known as how to represent numerical value of a phasor. For example, a phasor can be drawn like this, or it can be like this, or it can be like this, okay, or it can be like this. So we sketch phasor on a two-dimensional plane. Depending on the sine wave, we sketch phasors like this. So as you know that phasor length is represents the amplitude, and the we have to take orientation also into consideration, whether it is like this or like this or like this. So we sketch phasor on a two-dimensional plane. So when you are sketching the phasors on two-dimensional plane, how to represent numerical value? There are some standard forms. We have to stick on to these forms, and that is what how to represent numerical value of a phasor. So before going into the numerical value of phasors, anyhow we are going to draw phasors on a two-dimensional plane. Now what I will do is I will going to divide the plane in two ways. So before representing the numerical value, first we have to divide the plane suitably. Now first what I will do is I will divide the plane by two mutually perpendicular axes. One is horizontal axis, another is a mutually perpendicular axis. So by having two axes which are mutually perpendicular to each other, we have divided the plane into four quadrants, is it not? Quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. And each quadrant is going to contain 90 degrees. So first, this is horizontal. So this to start with, this is called as 0 degrees. 0 degrees. Now each quadrant is going to contain 90 degrees. Now let us measure angle in anti-clockwise direction like this. So if you measure this angle, then it is going to be called plus 90 degrees. When you are measuring angle in anti-clockwise direction, it is taken with plus sign. So plus 90 degree or plus pi by 2 radians. Next, if you measure this angle, then it is going to be plus 180 degrees or plus pi radians. Plus pi radians. Next, this angle is measured as plus 270 or plus 270 degrees. Next, if you measure this angle, then you are going to come back to 360 degrees or 2 pi radians. So angles measured in anti-clockwise direction are taken with plus sign. So this is one way. You can also divide, you can also measure angle in clockwise direction like this. So again this is taken as 0 degrees. Next, if you measure this angle, then it is going to be minus 90 degrees or minus pi by 2 radians. Minus pi by 2 radians. Next is this angle plus minus 270 degrees or minus 3 pi by 2. Here also it is plus 3 pi by 2. Minus 3 pi by 2, this angle. Sorry. This angle is not minus 270, it is minus 180 degrees or minus pi radians. Minus pi radians. Next, if you measure this angle, then it is going to be minus 3 pi by 2 radians or minus 270 degrees. So next, measuring this angle, you are coming back to this axis. This is what is called as minus 360 degrees or minus 2 pi radians. So first preliminary thing is, first we have to divide the plane into 4 quadrants and you have to specify the angles. This is one way of defining the plane. Another way of defining the plane is again by having a set of mutually perpendicular axes. Mutually perpendicular axis. Another way of dividing the plane. Now this is again horizontal axis, vertical axis. Now in this case, horizontal axis is called as real axis. Real axis. This is what is called as imaginary axis. Perpendicular. Next, this is origin. So this is any number on this real axis on this side is represented as plus a. Plus a. Next, on this side it is represented as minus a. Any number. Any number. Next, on this side it is represented as JB. Because this is imaginary axis, so we use J notation, and number on this line is indicated as B plus JB, and on this side it is minus JB. So A is called as A, real axis component, B is what is called as imaginary axis component. So A is also a number, B is also a number, but we have to distinguish A and B. So B is distinguished from A by having J notation. So this is another way of dividing the plane. So in this class we understood the division of plane into by two methods, and having understood this, next comes the question how to represent the numerical value of phasors, that I will take up in the next class. Thank you.